Okay, welcome to the Web Performance Working Group. This call will be recorded and posted online as always. On the agenda, just first of all, for administrative, on the administrative side of things, our next call is 2 weeks from now, March 18th, same time. If this is a problem, please reach out to one of the chairs and we'll try to figure out a solution. Otherwise, I think we can get started today. What we had in mind is to essentially go through a bunch of issues for the first half of the call, and then talk a bit about event timing and scroll timing over the second half of the call. And I think we can get started with an update on resource timing and fetch integration that is long overdue. So Noam, do you want to update the group?
Yes, sure. So up until now, resource timing itself, in the spec itself, specifies at which point during network request response the different measurements should take place. And so this kind of creates a parallel algorithm to what already exists in Fetch. So resource timing describes in prose something that is formally defined elsewhere. What we're trying to do now, what we are doing now is define inside Fetch the different points where when the metrics should be taken, and which raises a few interesting places where the definition might be vague or might be very open to implementation. So we're trying to make all of that a lot more precise. Part of it will still be a little vague because they're not even in Fetch, but rather in HTTP, TLS, DNS, and all those. But for now, what we are defining inside Fetch instead of resource timing, where Fetch will gather all the different metrics and pass them to resource timing for to normalize and to coarsen and to do all the stuff before it's exposed to the web developers. And that's the main idea.
Yeah. So I think the interesting bit is that a lot of the processing model and the somewhat conflicting getting algorithms will essentially move to Fetch. We'll create a structure in Fetch that contains all that information, and then report that in the resource timing spec. But essentially, Fetch will call into the resource timing spec to queue up those entries or report that information that will then queue up entries. And it's a design that's much more it really resembles how implementations currently do that, at least for Chromium and WebKit. I'm less familiar with how Firefox is implementing, but I'm somewhat assuming that it's similar. So I think it's a good way to make the spec closer to what implementations do, and make it more precise. And in the process, there's a bunch of scrutiny related to the what are the entries exposing, and that is not always super well defined. And hopefully, we'll find ourselves at the end of this refactoring with all the entries being well defined as to what they expose and what are their semantics. So I'm excited about that.
I have two questions. One is, so navigation timing is built on top of a lot of resource timing things. Are we going to be tackling any of the navigation timing stuff as part of this, or is that like phase 2?
You can say it's phase 2. I'm starting with the resource timing, and we'll have the infrastructure, because I'll probably do copying and pasting of how I did, how we register, we bookkeep inside Fetch, and then report it to another API. So it will probably be similar. Like, instead of counting how long it took to redirect, I would count how many redirects there were, and take that bookkeeping and report to navigation timing. It's probably going to be a lot easier.
Good. And then the second question is the goal to try to maintain compatibility with how we report timings today, or are there any obvious things that we're going to need to change as a result of being more integrated with Spec? Like, is there going to be a, browsers that are closer to the new version with based on Fetch? Are they going to be reporting slightly different numbers than other browsers for any reason? Or is the goal to maintain Compat?
I think the answer is somewhere in the middle. We want the specification to be well defined. Otherwise, there could be a difference between different versions of the same browser engines just because. And we want the web platform test to reflect like a well-defined specification. I think if there are we use the implementation. If there are parts in the implementation that actually can be reverse engineers to being well defined, then it will be pretty close. And in cases where it's actually not that well defined, it might be beneficial to change the implementation. So it's like a negotiation, you could say.
Yeah, I think the goal is to reach definitely we cannot break content, but also, in terms of timings, there are a lot of things that were a may or implementation, open to interpretation, that we would love to clamp down if possible. So yeah.
And I'm today there are many cases where different UAs diverge based on exactly what they're reporting in subtle ways, right? And I'm sure that'll always be the case. I'm just if there's anything that we need to redefine what TCP start means for whatever reason, it's I just want us to be very transparent about that, especially for anybody that's looking at the spec for what an older browser might be implementing versus a new browser, just for future analytics providers to understand if those are the case. I just want us to be open about that.
Yeah. Specifically, if we get to the to the practicality, the issues that were raised, a lot of them have to do with what's exposed with a timing allow origin versus not exposed. And the other things were really about things that had issues about them before, like worker start, that the definition wasn't clear. And
I hope to cover that in a few minutes as well.
Yeah, I think that all the things that are... Sorry, go ahead.
Sorry, I finished.
Oh, okay. So basically, all the things that are somewhat contentious or blogging are on the on the agenda to discuss here. One is worker start, and then the Next hop protocol, it seems like it would be better to tower protect it generally, and we probably need to do that. But we'll talk about that in a bit. Other resource timing questions, or can we move on to worker start? Cool. Okay. So thanks. Thanks, Noam.
Sure.
Yeah, and yeah, Nick, do you want to talk about worker start?
Yeah.
I will take over scribing.
Thanks. Yeah, so kind of a follow-up to what Noam was talking about, and I think fetch integration will probably actually help with some of the things that I'm going to talk about as well. Let me try to share. And let me know once somebody sees my slide deck.
We can see it.
Okay, cool, thank you. Okay, so I'm going to talk about worker start in both the navigation timing and resource timing specs, although what I'm trying to first change is the navigation timing spec, and maybe that's backwards. Maybe I should be tackling this from the resource timing point of view, so Noam and I can coordinate a little bit better. So worker start is some nebulous term meant to capture when a service worker started up for the current navigation, for a navigation timings point of view at least. One of the original goals of worker start was to help measure worker startup cost. In other words, like the serial cost, the synchronous cost of how long a service worker took to start up, because it's kind of in the critical path. Just taking a look today at where we are with it, I think we added it to the spec back in 2015 or so. It's implemented in Chrome. I believe the attributes exist in both Safari and Firefox, though I've never seen them be anything but 0. So I'm not sure if I'm just testing wrong, or if those timestamps don't seem to be populated at the moment. I don't know if either of those representatives have any knowledge about that, but today the only place that I could find a filled-in timestamp for worker start was in Chrome. Notably, in Chrome, worker start is always, as far as I can tell, less than or equal to fetch start. So if you look at our current, well, I guess this is the resource timing diagram, but I meant to share the navigation timing diagram. The worker start kind of happens ahead of redirects in it, according to some definitions of worker start in some of our specs. So part of the reason why I'm being so nebulous about what I'm talking about is that it's actually kind of confusing what worker start means or what we're intending to do with it. And I think there's actually quite a few different things that we can improve with the definition of worker start in both navigation timing and resource timing specs. The very first thing is just that worker start, as I showed you on the last slide, in the visual diagram that we have, it's missing from that diagram. So that should be, there is an open issue to request to ask worker start to the diagram. Once I started looking at, because I was trying to figure out exactly where it should fit, right, in the diagram. That was actually what triggered all of this diving into these issues. Is there is a single open issue to add it to the diagram? I was like, okay, so where should it fit? Started reading through the processing model, and there's I found a bunch of edge cases where the actual, if you implemented it exactly like the processing model in navigation timing, it would either be not what we want or incorrect or just kind of funky to work with. So for example, if you have any same origin redirects, let's say you just have a single same origin redirect, worker start will always be 0 according to the current processing model, even if it's just same origin redirects. If for some reason that wasn't the case, if we didn't 0 it out, it would only be for the final document, meaning the startup time from the first resource would not actually be captured, and only the non-startup time, the 0 time for the second resource, would be captured. If there's any cross-origin redirects, then currently the worker start time is that of the cross-origin and not your final origin, according to the processing model, and that's definitely information leakage that we want to avoid. For example, the same origin check to determine what same origin means does not work if there are no redirects. Like there's just, it behaves in the opposite way that you want. So those things can be fixed, right? We can work through the document to fix those. In discussing this a little bit further, both in the nav timing and resource timing repo, there's some questions about when worker start should be in the diagram. Should it be before fetch start or should it be after? I'm going to jump ahead just a moment to the current diagram that I'm proposing. Fetch start, again, is after all your redirects. It's the fetch of the last document, and it's right before the app cache. The worker start, we are suggesting happens before then, right? It's before any redirects. It's when the worker had to start up, like the amount of time or the timestamp when a worker literally had to start up. But according to our definitions of the attribute in resource timing and the definition in nav timing, but not the processing model, it's actually the opposite. So in some cases, we are defining worker start kind of in terms of it having to be after fetch start. There's a big discussion in the resource timing as well, and I think there seems to be general consensus around worker start should happen before fetch start, meaning like worker start should be the time where the service worker started up, and fetch start should be after that when the actual fetch for the final resource started in that worker. But the two are inconsistent today in themselves and between each other. And then it kind of goes back to the point of it actually just makes the original goal, which is how do I measure how long it took for the synchronous service worker startup time to happen? Originally we had defined it, I guess, in our original pull requests and emails, describing it as fetch start minus worker start would be your startup time, assuming that fetch start happens after worker start. I know that this is how we implement MPulse. I don't know if any other analytics providers are actually exposing service worker time today. So if there are examples out there, I'd love to know if other people are defining it in any different way at all. But you can't actually use it that way if there are any redirects at all, because the redirects happen after the start of worker start and before fetch start. So if you did this calculation and you had a redirect, you would also be including redirect time. We don't ever talk about service worker scopes, because you could actually have a service worker, multiple service workers in your synchronous critical line of measurement for different scopes, assuming you're redirecting back and forth between different subpaths on your domain. So there's been a proposal to actually change this a little bit to make it easier to have some sort of worker ready timestamp, or some, besides just having the start timestamp, have the end timestamp as well, so that you could definitively say the service worker started up now and ended now. And maybe that's a thing that we can work on later. It also gets a little confusing if you have multiple scopes, because maybe you actually have multiple service workers starting up. So maybe we want to do something even more different than that. I'm not sure. Again, in the anti-spec, we're not using the same words or processing model or links as a resource timing spec, especially as it relates to integration with fetch. So I'm really glad that GNOME's working on this. And again, maybe we should work on this from the point of view of RT first, and then backport it to nav timing, and then it'll all be magical. And then finally, we don't have we have very little web platform test coverage on this. So there's only a few tests in nav timing checking for its existence, not on any of its functionality or value, and there's only a single test in resource timing that looks at it. So I think we definitely want to lock in however we work on this after we make some changes. That's kind of like the scope of the world. Today, if you tried to implement worker start, if Mozilla or Safari wanted to, I think they would be upset with where the state of the processing model and such are. So I do have a pull request in the navigation timing repo to address some of these issues. Like here's the new diagram I hacked out of SVG to kind of place worker start in the diagram. And then some of the cases of what I was just talking about are addressed as well. So the edge cases in the processing model, I think we have all these figured out we're more consistent with that worker start should happen before fetch start. And it works in cases of redirects and stuff. But there's still a lot of things here, like everything on most of the stuff on the right-hand side is not yet addressed. And I didn't want to tackle more in this pull request, but I think it actually makes sense to either pause this pull request or get it in and then work through the changes that GNOME's working on to fix the rest. So that's kind of where we are. Like in addition to that pull request, I think we need to do all these things. We need to sync better with the resource timing spec and its integration with fetch, improve the web platform tests. We need to figure out if multiple same origin service workers in different scopes should matter here, and if we want to expose all of them or the sum of their time or do something else crazy. And that's kind of related to worker ready time. So anyway, I just kind of wanted to bring everyone up to speed where it's at, and maybe decide if we do want to continue with this pull request as is and get it in with the minor fixes that it has, and then wait for all the other outstanding challenges for fetch integration.
Yeah, I have something that came while you were talking about the redirects. Seems like the problem here is that everything in resource timing is has a one-to-one relationship with a request. Like there's only one point in time where redirects start, only one point in time where the response ends. But there could be multiple times where a worker would start.
Mm-hmm.
Like it feels a little bit like it needs to be several worker starts, the same way there maybe would be several redirects. I'm wondering if there should be like a different entry at all for measuring workers rather than put it as part of the request. It seems a little like maybe the worker start is not part of the request in a way.
Yeah, like once I started thinking through the different scope service workers, and I mean, instead of having like a single start and stop timestamp, if all we're really trying to answer is what was the total critical path time we spent starting up service workers, we could just expose that as a duration, right? We could say that multiple service workers exist. Maybe here's their total time. We kind of work around that in resource timing if there are multiple redirects by redirect start being the start of the first redirect and redirect end being the end of the last redirect. So they all kind of collapse into that nebulous area. But I think service worker, like you could have a service worker start and end at multiple different points in time, and many redirects in between as well, right? So maybe it makes more sense not to have a worker start and worker ready, but have like a worker startup total time thing.
Yeah, because otherwise you would also count like the time of the redirects that happened in between.
Right. Yep. Yeah. Exactly.
Hey Nick, this is so great that there's some effort being put into this. I really appreciate it. I just want to say for the record that Mozilla looks at this, we're just looking at the service workers for fetch. So we started after fetch start, and we have this thing called fetch event synthesize response end at the beginning of app cache. So I'm just wondering, like, we like the bracketing approach. That is kind of what we're interested in. But the thing is, it's like they're going to be different things. So I'm taking what GNOME has to say about perhaps there's multiple start and endpoints to heart, and like wondering if we need a more fine-grained approach here.
Yeah. Yeah, and the confusion today around where does worker start fall, and it kind of depends on your definition of fetch start. I think in some cases it's like the entry point into the fetch spec, in which case worker start would be after fetch start. in the resource timing issue around this, fetch start is more of, the time when not the entry into the fetch spec, but the time when the browser intends to go. I don't know. Like, I'm not going to define it well because I don't know the fetch spec well enough. But like at a later point. So if we actually remove our dependency on worker start being a timestamp, we can actually just report total time or something. Then it actually kind of gets around some of those issues as well, maybe.
I wonder if there could just, well, I don't know.
No, go ahead, brainstorm.
No, it makes sense to me that when there are things that are not one-to-one in the performance APIs, that there are new entries for them. Like you had 3 workers, have a start and end time for each one of them. Call it type worker instead of type resource. Don't even need a new. Can be inside the resource timing, but like it's point in time. Just report them like as you report other points in time. Like trying to aggregate them into an existing one feels a little bit like we're trying to avoid that, but should we? Like, is that correct?
Right. And that would certainly help later in debugging. If one of many was slower than the others, you could at least know the ordering in which they happened, and hopefully be able to figure that out.
Yeah, and you can even imagine doing this not just for service workers. Like in the future, like have a startup time for dedicated workers. Like no need to decide on that right now, but like like it makes sense to me that if worker startup time is something that's worth measuring, let's measure it instead of aggregating it.
And very similarly, I mean, redirects could use the same origin redirects could use the same breakdown.
Yeah, and we've had open issue about that for years now, about like exposing same origin redirects, and yeah, it could be interesting to think of both of them as a similar problem. What I thought of doing, because this seems like an area where the service workers working group would have a lot of both knowledge of service worker processing as well as experience from working with years with the service worker consumers that are the people that are trying to collect that data. I thought it might be interesting to have a joint meeting with the service workers working group. I haven't coordinated that at all, but it seems like something that would tend to be in the on the earlier side of the day for PST folks, because there are a lot of folks based out of Japan that are involved. So I thought of scheduling a call at some point. I don't know if this is of interest to everyone here. If it is, please let me know, and I can try to see how I can, make add you to the invite, but then also maybe try to make time zones work if PST folks are interested in joining. Yeah, so please ping me and I will try to coordinate that call, and we can then deep dive into whether aggregation would work or separate entries or something else entirely. Does that make sense to folks?
Sounds great to me.
Cool. Totally.
Yep.
Cool. And with that, I think maybe we'll switch things around to make sure we have enough time for the event timing, or maybe I can just spend 1 minute talking about each one of the issues. Like there are 2 issues on the agenda that are Like, one is that currently performance.timeOrigin is not clamped, and it's exposing the raw time. There is no particular vulnerability that we've found with this. At the same time, there's no particular use case either, so it seemed healthier to just clamp it. If you find, and there's an open PR to do that, if you have any strong objections to that, feel free to chime in on the issue. Similarly, for the next hop protocol, it seems like it would be better to make it tau protected. There are some potential issues with not doing that, and it seems safer to do that. And there's no strict, like, I can't think of a strong use case that would prevent us from doing that. Again, if you have strong objections to us taking that course, please chime in on the issue. And with that, I think we can move over to Nicholas and event timing and scroll timing.
All right. So I wanted to talk about how we're thinking on improving the current responsiveness metric that on the Chrome side we've been really pushing on, which right now is FID. So first, let me talk about a brief recap of what FID is. I think most of you are familiar with it already, but basically FID is the delta between two different timestamps. One is the event timestamp of basically when the user input occurred. And the other timestamp is the time right before event handlers for that event are about to begin running. So it doesn't include the runtime of those event handlers. And we compute that delta for the first of one of four options: key down, mouse down, pointer down, which is followed by pointer up, or click. So basically, the idea is to capture key or taps or click interactions. Some places where we've been successful with FID are firstly encouraging people to basically break up their long tasks, because the idea of FID is to penalize websites where the user interacts while it is performing a really long task, because that should cause the site to have a long FID, because basically the task cannot stop. And so the browser will have to wait a while before it can begin to process the input. The other success that we've had is that it has helped us in both the browser side as well as some developers, has helped us surface more tap delay issues. Right now on mobile, in some websites that don't have mobile optimized viewports, you can basically double tap to zoom. But the problem is that for those cases, if the user taps, we have to wait in case the user double taps. And if they don't, then that means that the first tap was a click. And so we have to treat it as a click. If they do tap again, then that means they just wanted to zoom in. And so with FID, we realized that there's a lot of sites that actually have this issue where the user taps are being delayed because of that behavior. And so some of those sites have fixed their viewports to not surface such behavior. And Chrome is also planning to try to make this pattern be harder to occur accidentally, because right now it's a little bit complicated how like basically when this happens versus when it doesn't. So that's another success that we've seen with FIT. That said, we do want to improve FIT because we're well aware of lots of its limitations. So today I wanted to talk about 3 ways that we'd like to improve FIT, 3 different avenues, basically. So one is to consider more than just the first input. It's just an obvious way of improving FIT, right? Right now, FIT just looks at the first one. Why not look at more than just the first one? The other thing is to potentially include scroll begins. Right now, FIT does not include scrolling. This is why the pointer down only counts if it is followed by pointer up. And finally, we want to evaluate a larger chunk of the end-to-end latency, because right now FIT only captures a very small portion of it. And so we're seeing that a lot of sites that have poor responsiveness actually have high FIT numbers because it simply does not capture the problems. So we want to improve on that. So for the first point, evaluating more than just the first, we're thinking of considering user interactions instead of individual events by themselves. So the idea is that when the user does a keyboard interaction, you can have, for example, key down and key up DOM events. And so we would like to look at them as a whole. Basically, generally, the key down will be the one that captures the update to the screen. But in certain sites, it's possible that the key up will have some effect on the website as well. And so we want to look at the total latency by all of those DOM events that are created when the user does a keyboard interaction. Similarly, we want to look at tap or drag interactions. So in this case, we're going to be looking at all the pointer events and synthetic events that are dispatched as a result of the user tapping. So pointer down, pointer up, touch start, touch end, mouse down, mouse up, click. So obviously, not all taps trigger all of this. For instance, touch events, they're not triggered on desktop or on mouse clicks. So a tap will basically contain a subset of these, but we want to look at basically for the tap interaction, what is the event latency of this interaction? Similarly, for drag, we want to look at the basically drag start and drag end parts of the interaction. So it's harder to reason about what happens when the user is moving the finger during the drag because, well, that could take a long time and so on. So we basically want to focus on the initial and final part of the drag. And finally, the third interaction, which is, in my opinion, the more the newer one to FIT is the scroll, because FIT, as I mentioned, does not capture scrolls at all right now, and scrolls are actually really common on websites, and so we want to make sure that we're capturing scrolls. That said, scrolls are not necessarily blocked on any event, so they're a little more complicated. I don't know if this is the case on all browsers, but on Chrome, you basically have to have non-passive listeners, so to block scrolling on events. So that's why I didn't set a specific set of events associated with it, because we want to measure the initial scroll latency. So this may not capture the event listeners that are triggered by the user gestures that cause the scroll, if that makes sense. So in order to associate events to interactions in the way that I described, where, for example, the key down and the key up together form a single interaction, we would like to enable developers to do this in a way that is relatively simple. Right now, it is somewhat possible with event timing, but not quite. Like, you could maybe play with the timestamps and try to figure it out like in a heuristic way, but it's not really easy to do so. So this is why I've proposed in the past to have something like an interaction ID, where a key down and a key up entry that share a common interaction will have a shared interaction ID. And similarly, this can be done for the other types of events, like pointer down with pointer up and so on. And then, of course, event timing may surface entries that do not belong to any interaction in the way we're currently defining them. And I think that's also OK. There can be a basically undefined interaction ID where this event just doesn't, sorry, this entry just doesn't correspond to any of the interactions we've defined. So that is my proposal for how to solve this problem, but happy to hear thoughts or ideas about how else we can associate events to interactions in a relatively simple way. The other problem with what I've mentioned is that right now there's no way to measure scroll performance. Obviously, you could basically try to measure it with event handlers, but that's going to introduce latency. And as I mentioned, the idea is that scrolling is not blocked on event handlers. So it's actually, if your site does have performance scrolling, it's actually impossible to measure this accurately right now. So I think we probably want to enable developers to measure scroll performance. One use case for this is that sometimes developers may force scrolling to happen in the JS thread, so basically in the slow path. And when that happens, I think they should be made aware that this is happening. And so when this happens, it's likely that their scroll delays are going to increase by quite a bit, because usually the compositor is much faster. And so this means that we need a way to measure the initial scroll reaction, which we call scroll begin, which is basically the latency between the touch move that triggers the scroll, or in general, the event timestamp that triggers the scroll, to the time when the browser first reacts to that scroll. Basically, the screen has changed as a result of that scroll gesture from the user. And there may also be some use cases for subsequent scroll reactions. So for example, imagine you do a long scroll. There are many frames that the browser needs to produce as a result of that user gesture. So the subsequent ones are called scroll updates. And my initial reaction is that they would probably be better addressed by the frame timing API, because what we care about there is, in some way, the frame latency of how quickly is the browser producing those scroll update frames. So with that in mind, there's two ideas that came up when I was thinking, how could we expose this to developers? One would be to basically extend event timing with a new entry that is a little bit artificial, in the sense that it doesn't have an associated event as the other entries do. So for the name, which is where we generally put the event type, we could do something like scroll begin, which is not the name of any event currently. Something like scroll could also be used, but that would be confusing because there is a scroll event which happens after scroll takes place. So I think that would be more confusing. And then the other idea is to basically just have a completely separate scroll timing entry, which could be called scroll timing or performance scroll timing or some other name. And the benefit is that we could expose both the scroll begin and potentially scroll updates in an easier way that way. And in addition, some of the event timing values just don't make sense for the scroll begin. For example, processing start and processing end, because there's no event handlers. Well, unless your scroll is blocked on the event handlers. And so it's debatable whether it's meaningful or not. But I worry that if we do it in event timing, the values of the attributes will be potentially very different. And so I'm not sure if it's probably more confusing than just having a different interface for the scroll values. So I'm hoping if people have thoughts on this or better ideas than the ones I came up with, then happy to hear about them. And then before discussion, the last thing that I wanted to touch on was evaluating the end-to-end latency. So this is a diagram that the speed metrics team did. So you can see initially on the left is when the user interacts with the page. So that's the event timestamp. And then there are some blocking tasks on the JS thread that prohibit the browser from reacting to the input. And then you can see the green part is where the JS thread starts reacting to the input by basically running the event handlers and whatnot. And then the first yellow star is the frame that is presented as a result of the event handlers running. But that's not necessarily the full end-to-end latency, because the event handlers may post tasks or fetches or any other asynchronous function that you can think of, right? There's so many right now. So those tasks are in red, basically, but they're in some sense ill-defined because it's hard to know exactly what should count as part of that end-to-end latency. Like, do set timeouts count? Probably not, but you could think if a developer wanted, they could basically process the event in a set timeout of 0, and then makes it hard to reason about what exactly are those red tasks. But assuming we could know what those red tasks are, then after they are done, we have the second yellow star, which is the full end-to-end. And so that would be the final goal of our metric. However, for the present, due to the heuristic nature and how complex it would be to track the red tasks, we're thinking of just looking at the yellow first star. So next frame presented on screen, which is already exposed in event timing via the duration value, the duration attribute value. And so I think I've mentioned what this slide is about. Basically, asynchronous work is really hard to track, and we don't want to accidentally say, the event takes longer than what it actually takes. And so for that reason, right now, we're focusing on the next frame presented on screen. In the future, we would like to explore looking at what those red tasks should be and how they look like. So those are our current thoughts on how we're working on creating a new responsiveness metric that is better than fit. So I'll open it up now for thoughts or questions, especially on interaction ID, on scroll timing, but any comment is also welcome.
I can comment maybe on the scroll. So the name idea, I think, is makes sense because it would fit nicely with existing frameworks or code that uses the event name for tracking event timing. So if that's a sufficient justification for this, then it has value. I mean, I see that it has value to have, and I don't think it matters much that there is no such event called scroll begin, because it's an indication for something that happened, even if it's not a predefined DOM event. And I'll be happy to actually have many more events, even if they're not specific DOM events.
Yeah.
On the other side, I think it would be very interesting to have more elaborate scroll timing information, I guess. So it's hard for me to judge. I'm just highlighting the advantage of the first proposal.
So for me, the main question there is how different do we expect scroll timing to be from event timing? If it's the exact same entry, just with a different observer, then yes, we might as well coalesce it, give it a separate name so that people can look for that specifically, but otherwise it makes sense for that to be the same entry. Where it, like, do you predict them to diverge at some point, and then we will have like properties on that entry that are only specific to scroll or only specific to events? And if that's the case, then it might be worthwhile to start with separate entries. And I don't know, like, I'd be interested in your opinions on the likelihood for that.
Even if they diverge, would it matter? Could we keep the original scroll begin for legacy purposes, or for those who are not interested in more granular scroll timing information?
We could, but we shouldn't plan for like it's not a very like we should aim for nicer APIs, I think, and this won't, like, if we'll end up having this as a duplicate, that wouldn't be ideal. So
yeah, and if we already predict we're gonna have to have a separate entry for scrolling later, it might make sense to just basically do it in a separate entry in the first place, I think, right?
Yeah.
And so I guess the question is what scroll update would require. And my intuition is that that one is harder to reason about as a single performance event timing entry. Because first of all, we don't want to expose all scroll updates. So we need some way to aggregate them. And so it's not clear to me how we want to aggregate them, but it's potentially the case that they would require different values than what you see already in event timing. Like duration for scroll update is not, I don't know how useful that is, right?
Yeah, because the updates are more about smoothness, right? Less about direct interaction or response to the user action.
Right, and so that's why I'm like, well, if we needed to include scroll update here, then it makes sense to have a new entry. But if it's possible to just have it as part of frame timing, then it could be okay to have the same kind of entry and just have scroll begin separately. So I'm also not sure.
So I don't remember the frame timing. Does it include the some attribution to events, or I forgot the definition?
I don't think it has attribution to events, but I'm not familiar with.
Hey, Nicholas, is my understanding correctly that scroll begin is basically just the purple area in the diagram that you have shown?
So it should be the same, which should expose for the next frame presented. So in this case, for scroll begin, I would say the diagram doesn't make as much sense in the sense that if it happens not in the JS thread, then there's no blocking tasks on JS thread, and there's no handlers that need to run before that frame happens. So some of that may not even exist. If it does happen in the JS thread, then the diagram still makes sense. And then we should still expose basically the next frame that is produced as a result of the touch move. Well, let's assume it's scrolling on mobile, right? Because touch move means basically scroll does not require touch move. But if it's on mobile, the next frame after the touch move that triggered the scroll, right? So the initial frame that started the scroll reaction. Does that make sense, or?
I guess so. There are basically two possible scenarios for it. Like one is the JS handler would be involved. The other one is there would not be involved, right?
That's right. In some cases, scroll happens without waiting on any handlers, and so in that case, there's no green part. In other cases, the event handlers block scrolling, and in that case, you still need to wait for the green part.
So it sounds like the reporting number will be like by model or something. So I wonder if that's something we want to say.
Right.
Just have some sort of like labeling, like this doesn't have JS involved or something like that.
Yeah, and so one way I was thinking that could be handled is by basically exposing the processing start and processing end for some event that blocks the scrolling. So for example, the entry is scroll begin, right? So if it's not blocked on handlers, then processing start and processing end will be 0. If it is blocked on handlers, then you set the processing start and processing end accordingly. And so that way developers will know, oh, my scrolling is being blocked in handlers. I should probably fix that because, well, unless you're intentionally doing it, then that's okay. But in general, that's a problem, right?
Yeah, okay. That makes sense. Thanks.
Sure. Yeah, you're muted.
Yeah, sorry. We are 3 minutes over. I don't know. I see that. So, like Peter, you raised your hand and breathe.
Yeah. First of all, Nicholas, thanks for the presentation. Yeah, I know we're 3 minutes over. Just like a quick question. From my side, I've been working with real world cases now that, let's say in May, we will see all this Web Vitals update going live in the algorithm. And just like a question of mine, which probably I would really like to present at the next time, like in the next meeting, that has certainly things to do with this specific, let's say, evaluation of the end-to-end interaction. I had a question, Nicola, if you can answer. The specific point where we say work kicked off by event handlers, what I see in some websites, people trying to just, let's say, skip some of the, let's say, the Web Vitals checks, at least from the SEO perspective. What they do is that they define the loading of some third-party snippets after the user has just scrolled. Okay, so that means that the event handler, the on-scroll handler, will run some async AJAX requests to pull, let's say, some snippets. Does this get caught from this point on in the, let's say, the red tasks bucket? Or is it something that we should implement some heuristics on?
Right. If it's on the scroll event,
yep,
it would probably be, I mean, either red or not even part of the diagram, depending on how you look at it. So yeah, that would be async work that's basically out of scope right now. But depending on how it's implemented, you could argue that it's part of the red part, or just not really, or shouldn't be captured. Like there's things like a click triggers an animation, and so those things, some async work is not really meant to be captured by red. So that's the difficulty.
One other thing to keep in mind is that if you're tracking all of the inputs and scrolls, like if future inputs are scrolled down by the fact that they kicked off some work on the first scroll, then that'll be captured like on the next input.
Okay, and yeah, and with that, I think we're really over.
Sorry for the delay.
Thanks all, and I hope to see y'all in a couple of weeks. I will send details regarding the service worker meeting once I'll have any, and yeah, let the folks interested know as well. Okay, thanks all, and cheers.
Thank you.
Bye.
Bye.